All right, now it's time to talk about the big story of the week, and possibly even one of the biggest stories of the last few months. And I feel like that there should be like trumpet music right now or something, because if you were curious as to when Intel would actually launch their fourth generation Xeon processors, consider your curiosity satisfied, because the answer is yesterday. Intel's long rumored Sapphire Rapids architecture is now official as of January the 10th. Biggest takeaways from the official coverage that we're seeing on all the great posts that were released yesterday are the inclusion of accelerators on the CPU die to help increase performance for specific workloads like SSL encryption, 5G, and networking that's built on Intel's DPDK. These features do curiously come with something called Intel On Demand, which is a service that allows you to purchase CPUs now for a reduced cost and then unlock those accelerators at a future date for an additional fee. There's even discussion for two of Stephen's favorite topics. That would be Optane and CXL. But Stephen, you have been on top of this release as we've been seeing it rolling forward to its inevitable conclusion. Tell us what stands out in this announcement for you.
Well, I think the takeaway here is that Sapphire Rapids gives Intel a really competitive server platform to AMD. I think that I can say that again. Yes, I know that AMD's Genoa is impressive. I know that there's some big numbers in there, but for the reality of the market, for the real world, for the way that people are using and buying and deploying these servers, Sapphire Rapids 100% is competitive with AMD Genoa. There's no reason that a company has to switch to AMD or in order to avoid, egg on their face, which was kind of the case previously until this announcement. So that being said, let me explain my conclusion here. So first off, we do have to say that AMD still leads in terms of some of the big sort of number benchmarky kind of things: core count, gigahertz, amount of system memory, number of memory channels, number of PCIe lanes, things like that. All of those things on a per socket basis, AMD is still in the lead on. AMD is easily competitive on many of the things that has been a sort of a challenge for Intel. In other words, things like total system throughput, IPC, which is the performance of each core, CXL, as you mentioned, the deployment of CXL and PCIe 5 and DDR5 memory. AMD's right there. AMD has also moved into some of Intel's markets with some special purpose CPUs in the Genoa launch, and many people expect them to launch even more special purpose CPUs on this same platform soon. That being said, Intel just ran a lap around AMD in terms of SKUs and delivering basically a CPU for everyone. And I think that that's the real message here of Sapphire Rapids, is that this is a CPU platform that scales basically everywhere, even down to the workstation, which earned about 2 seconds of mention during the announcement. But yeah, there are Xeon Sapphire Rapids workstation CPUs all the way up through the data center, the cloud, embedded, IoT, networking, all the way into HPC. That is the story here. The story is that Intel is delivering a next generation server platform for literally everywhere servers are going to be deployed. Now let's talk about some specifics. So first off, Sapphire Rapids basically ups what you expect to be upped. It uses a new core. It has a bunch of new accelerators, some of which are really, really impressive, doing things like network offloads, encryption, video processing, machine learning processing, all these things. The deep learning boost is up to 96% quicker. The quick assist technology uses 84% less cores. A lot of these things are really, really impressive. The problem with accelerators on die, though, is that they're expensive, because basically you have to spend all this money developing them, deploying them. You actually have to create them and physically on the die and then ship them. And that makes the chips more expensive, because you're buying a chip that has CPUs and caches and IO, yeah, but it also has these accelerator blocks. And customers may or may not want to use those, because remember, these systems are not, I mean, this is not a general purpose platform. This is an everything platform for every purpose. And if you're deploying, vRAN in a 5G tower, you have very different requirements than if you're building an HPC cluster to do machine learning processing, or a storage server or a network device or something. And all of those need their own special complement of accelerators. So instead of making 500 SKUs, what Intel has done is made a pretty flexible platform. It's flexible first in terms of what you're actually buying. There's essentially three kind of physical form factors here. There's a monolithic chip that is basically everything on one piece of silicon, just like it's always been done for the history of computing. There's and that kind of is the leader in terms of price, in terms of power efficiency, in terms of kind of what you're going to get. You're going to buy just a single CPU, a single chip. It doesn't have too many cores, but it's got everything you need sort of on one. Then there's a tile-based chip, which is sort of how Intel gets up to 60 cores on a single processor. It also includes a lot more functionality. It's a lot more stuff, kind of what Apple's doing with the M1 Pro and Max and all that kind of stuff. And this also uses Intel's EMIB technology to kind of, put multiple tiles on the same thing, just like their Ponte Vecchio and the Falcon Shores and all these other, things that they've done recently. So this kind of points the new direction that Intel's going to take with this tile-based architecture. And that gives you a lot more stuff, basically. And then finally, there's the XBM, which is the tile-based, but also includes high bandwidth memory on chip, which again is kind of what Apple's doing, but not with HBM. And essentially what that is that's the ultra high performance core for HPC applications. And I think that may be a dark horse for enterprise and cloud applications too. If you got something that's really memory constrained and you want it to just rock with memory, well, the new Xeon Max is pretty amazing in terms of memory because it's got all this high bandwidth memory right there on the core. Anyway, so you've got these three physical form factors. Each of those includes all sorts of accelerators on the chip. And when we talk about accelerators, there are a ton of them. But probably the big kind of headline stories are Quick Assist, which Intel has had for a while, but they've improved it now, which allows you to kind of offload a bunch of things like compression and crypto and stuff like that. There's the data streaming accelerator, which is all about moving data around for high performance and data analytics applications. There's the dynamic load balancer, DLB, which is all about moving data around for things like packets and networking. And then there's the IAA, in-memory analytics accelerator, which again is back for big data and analytics and databases and so on. It can get a little confusing because seriously, there's probably 20 different accelerators here. And as we said, most of these accelerators are on most of the chips, but most of them are turned off. And that's what Tom was talking about here a second ago. Intel's going to have this on-demand thing, which means that you can basically turn on, you can activate a feature that is physically present on your CPU. And I know you're thinking, oh, that's like BMW with their heated seats that you got to pay for. And that's not really what Intel's going for here. I think what this is all about is allowing Intel to not have to produce an infinite number of SKUs. They can produce a chip that then can be licensed, maybe even before the customer buys it. Maybe the customer never even sees this on-demand activity. Maybe they just buy a server with these four things turned on, and it gets shipped to them, and it is literally the same chip as if they had gotten it without those things turned on. But it's not like it's dynamic. It's just we're making one thing, and we can use it in multiple applications. And frankly, I think that's smart. Because again, Intel's goal here is to serve every market from the smallest to the largest with a reasonable number of chips. What do you think about that story, Tom?
So I think it's a really fascinating way that someone who looks at the chip market and realizes that they need to have better intelligence on how to package these things would go about doing it. And let's be fair, we're Pat Gelsinger fanboys. We've said that a number of times, but I think this is actually this is an engineering solution to a product problem, and I love it. So think about it like this: you've got a chip that has these accelerators turned on, and there's a mix of accelerators, right? So something like 50 SKUs that Intel has right now, which is awesome, instead of like 500 of them, because every one of those little accelerator combinations could cause a different SKU to be produced. And let's be clear, there are some chips you can buy that just don't have these accelerators, period. They're just missing from the die. And then there are some who have them, but you don't necessarily have to turn them on. So where would that come in valuable? So let's say you're doing a deployment of some new application or something like that, and you're like, okay, I know I need SSL and I know I need this other thing, but I'm not sure if I want to use DPDK or not. Like, I've got these ideas, but man, I have to make this decision right now. Like, if I buy the chip that doesn't have the DPDK acceleration in it, I can't use it. Intel said, hey, don't worry about it. Use Intel on demand, and you can enable it later. So brilliant. I don't have to, if I have a choice between two different chips, I can totally pick the better one. But here's the value. Once you turn that on, I know that you're using it. You're licensed to use it, which means I can track the revenue that given accelerator provides to the system. And we've seen this with licensing schemes a lot. Even if you make the license practically like free, like as little as possible, what you're really doing is tracking the usage and you're collecting data. So 75% of the people who use these two accelerators also use this other one. So when someone in that line of business tries to go and buy a chip, my recommendation is no, don't buy that one, buy this one, because the odds are good you're going to want to use that. And in these situations, these two accelerators are never really used together. So we're going to reduce that SKU out of our lineup. This allows them to really position product for the market that's buying it. So like you said, Intel wants to be the everything CPU company, but they don't want to be the everything in the catalog CPU manufacturer. We don't want to have 1,000 SKUs for every possible combination of accelerators you could ever need. But boy, once we have the right analytics, we just happen to have everything you could possibly want, because those are the things that you're buying. Plus, it allows them to know where to allocate resources inside of Intel. Man, everybody's using the SSL encryption. We need to make sure that that team has enough people to produce things. Now, the only thing I will say, and I've got to say this because I'm the security guy, having this many accelerators inside of a system, especially if they're just laying fallow and not being actively used because you didn't buy the on-demand license, doesn't mean that they're not a security attack surface. In fact, I would say that if Intel suddenly gets a report that the 5G accelerator on that chip is being used and you didn't license it, that should throw a huge security alert, because it means somebody found a backdoor into the system, and you need to get that patch. So ultimately, I think this is going to be a good thing for Intel, and it kind of leads to that whole software-defined future. I mean, we've talked about it for a lot of, we built the technology, we put the technology in there. You're not necessarily using the technology right now, but boy, all you got to do is buy this extra $9.95 a month license, and suddenly you can get all this cool technology.
Yeah, and I think it's important to point out, too, that it looks from the pricing, at least the list pricing. Now, remember, nobody pays list pricing for servers. From the list pricing, it looks like Intel really isn't even charging for these accelerators when you're not using them, when they're turned off. They really only do charge when you turn on the on-demand license, which is pretty cool. They're basically, putting the silicon out there and then charging only the people that want them to some extent. It's price competitive with AMD. Let's dive into a couple more interesting areas. Now, you did mention, of course, Optane. This release includes the Persistent Memory 300 series, codename ProPass, which we've basically known about forever. We've been expecting this for a long time. We got it teased at our field day events in 2022. We've been reading about it. There was a leak earlier, I think last week, of what it is. Essentially, ProPass is DDR5 Optane, and that's great. It allows you to accelerate performance. It's a lot faster than the previous Optane ever was, and it works fine. One note that I do have to make is that if you do use Optane persistent memory, it does slow down system memory somewhat. You can't use the fastest DDR5, but you can't use the fastest DDR5 on every Sapphire Rapids SKU anyway. So it's not like it's going to slow down to like DDR3 speed or something like that. Uh, the other thing that I'll point out, CXL, yes, as the host of Utilizing CXL podcast, a weekly podcast here on Gestalt IT, I have to point out that Intel does indeed support CXL, and we kind of knew that because we've been actually seeing Sapphire Rapids development systems with CXL running for like a year. So this was the worst kept secret in the industry. However, there's a big head scratcher here, because all those systems, all those development systems, as we've been talking about all season long on Utilizing CXL, they're memory expansion. Well, guess what? Sapphire Rapids doesn't officially support memory expansion on CXL. And if you're like, wait, what? Yeah, that's true. Memory buffers is a so-called CXL Type 3. That's not officially supported in the release version of Sapphire Rapids. In fact, the Type 1 and Type 2 are honestly not all that compelling. Most people are really looking at Type 3 as sort of the initial CXL rollout. AMD does support it in Genoa. Intel doesn't. With that being said, I wouldn't worry too much. They're going to support it, obviously, because we know it works. Because like I said, we've been seeing it for a year. It's the development platform for all these things. I think that Intel is just being really cautious about rolling this new thing out and making sure that it's qualified before they say that it's qualified, which, I'll give them some props for. Let me just say, again, as somebody who focuses a lot on CXL, it's going to be supported. Hold your horses. It's fine. Similarly, Intel, kind of conversely, supports 2 DPC memory, whereas AMD doesn't yet. But there again, hold your horses. Don't count on that. I think AMD is going to support that too. It's just a thing. Another thing you might hear people talking about is the fact that AMD's got Intel beat, and I actually mentioned it earlier, in terms of the number of PCIe channels and memory channels and cores. But there's a big asterisk there, and that's that Intel actually has AMD beat in terms of all those things. And you might be saying, wait, what? Because Intel supports 4 and 8 socket configurations with Sapphire Rapids. Now, here's a little weird thing. So Intel had 4 and 8 in the Ice Lake generation, but it wasn't really Ice Lake. Cooper Lake was basically Sky Lake, which was the previous generation, kind of revved halfway to Ice Lake in order to support 4 and 8 for hyperscalers, because they're kind of the only people using like an 8-socket configuration. Well, Sapphire Rapids finally gets rid of that weird situation where you had kind of, generation 2.5 and generation 3. And now it's just all Gen 4, and Sapphire Rapids does all that. And Sapphire Rapids has enough cores, and the cores are good enough that in many cases, you may not even need to have a 4-socket or even a 2-socket configuration. In fact, I think that Intel is going to sell a ton of single-socket Xeons in the 4th generation because they're just really, really good. They're also, incidentally, lower power than the AMD systems. And as Serve the Home shows, the whole system ends up being lower powered, even though it delivers the performance of like a dual socket and a single socket, which is just great overall. So I think that's going to be a really compelling use case. I think, some people are going to step up to a dual socket, but a lot of those are going to be systems that maybe would have been a 4-socket earlier, or maybe would have been an expensive dual socket solution. Now there may be a cheaper dual socket. Similarly, the ones who need the absolute most cores, they can do an 8-core Sapphire Rapids system, and that includes all the PCI times 8, all the memory times 8, all the CXL times 8. And again, another weird thing about CXL is that AMD only supports CXL on a subset of the PCIe lanes, but Intel supports it on all the lanes. Intel so far only allows you to have 4 memory or expansion modules over CXL, but again, I think that that's going to be increased in the future. And essentially, back to what I started with here, Sapphire Rapids is the everything platform because it goes all the way from single socket workstation and single socket, embedded IoT device, all the way up to 8-socket monster memory, monster device with accelerators and CXL and Optane memory and all this kind of stuff. Everything is supported and will be supported soon. So again, that's, I think, kind of the angle and the way to look at this. Yeah, AMD still has them beat in terms of the number of cores per socket and some of this other stuff, but Intel has put together a platform that is essentially competitive everywhere AMD plays and beyond.